Good day, students, and Happy New Year. This is topic 4, lesson 1, properties of parallelograms. So the standard that we're going to be working with today is GCO 311, and that pretty much states that we are going to prove theorems about parallelograms and then use those theorems about parallelograms to solve problems. So at the end of this lesson, you should be able to answer this question. What can you conclude about the sides, angles, and diagonals of a parallelogram? Okay, so the video that you see here for your vocabulary is already a video that has been inserted into your class notebook. So if you want to take this time now to pause this video to take a look at the video that's in your notebook, you may do so now. So, looking at the information that we received from the video, we know that a quadrilateral is a polygon with 4 sides. And we also know from the video that a parallelogram is a quadrilateral that has 2 pairs of parallel sides. So as you can see here in the picture, we have side BC. We see that's parallel to side AD. And we also have side AB, and we see that's parallel to side CD. Okay, so now we're going to go ahead and go over some properties that were discussed in the video of parallelograms. So the first property that we have here is that if a quadrilateral is a parallelogram, then its opposite sides are equal. We can also say that they are congruent. So as you can see, based on the markings, side AD is equal to side BC based on the marking that we have here. And side AB with the 2 tick marks is congruent or equal to the side CD. The next property or theorem that we have for a parallelogram states that if a quadrilateral is a parallelogram, then its diagonals bisect each other. So as you can see, we have 2 diagonals. We have diagonal AC and we have diagonal BD. And based on the markings that you see, diagonal AC and DB or BD are intersecting each other or bisecting each other. So that creates 2 pairs of congruent segments. So AE is equal to the segment CE, and segment BE is equal to the segment DE. So the next property or theorem that we can discuss for a parallelogram is that if a quadrilateral is a parallelogram, then its opposite angles are equal, or we can also say congruent. So as you can see by the markings, we have the measure of angle B, which is located here with 2 arcs, is equal to the measure of angle D. And the same thing is true with angle A and angle C. These 2 opposite angles are congruent. So when it says opposite angles, it really means non-consecutive angles. And what does non-consecutive mean? Well, it means that we have 2 angles that do not come right after another. So they are directly across from each other. Okay. The next property, this property was actually not mentioned in the video, but it is another property of parallelograms. And it states if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So that means we just talked about consecutive. So consecutive means one after another. So as you can see, angle A and angle D are one after another, right next to each other. And these 2 angles together, their sum is 180 degrees, making these 2 angles supplementary. This is also true for another pair of angles, which is the measure of angle B plus the measure of angle C. That also equals 180 degrees. We can also say the measure of angle A plus the measure of angle B. That also equals 180 degrees. And we can also say the measure of angle C plus the measure of angle D also equals 180 degrees. So there are 4 pairs of angles within this parallelogram that are supplementary. All right, so we're going to go ahead over to the lesson notes, and this is the teacher model where I do it. So you're going to follow along with the 4 examples. So example number 1 states that in a parallelogram PQRS, we have PQ as being 17.5. So PQ is right here. I'm going to go ahead and highlight that side. It states that ST is 18, so ST is a part of the diagonal here of SQ. And then we have the measure of angle QRS. So this full angle right here says it's 110 degrees. And they want us to find each measure and then also explain. So when it says explain, that means we're going to state what property was used. So let's start with RS. We're trying to find RS. So I see here RS, let's go ahead and highlight RS, I see is opposite to PQ. And what do we know about opposite sides of a parallelogram? Well, we know that they are congruent. So because RS is opposite and congruent to PQ, that means that they share the same measure, which is 17.5. So the property that was used was opposite sides are congruent. All right, let's look at QT. So QT is a part of the diagonal QS. Actually, let's make this a different color so that way we don't get confused. So QS is this diagonal, and we're trying to find QT. We're trying to find this segment right here. Well, QT is a part of that diagonal QS, and what do we know about the diagonals of a parallelogram? Well, we know that the diagonals bisect each other. So that means that these 2 segments, QT and ST, are congruent, and PT and RT are congruent. So if that's true, that means that QT is equal also to the segment of ST. And if it's equal to the segment of ST, that means that their measures are equal, so that means it's also 18. So what property was used? Well, we can say that the diagonals bisect each other. That was the property that was used. That looks like an F. Let me change that. Each other. All right, so let's look at the next one. The next one says the measure of angle PQR. So PQR is this angle right here. So they gave me the measure of angle QRS, which is the angle of 110 degrees. And I see that PQR is right next to QRS. So if there are 2 angles next to each other, then I know that these 2 angles are consecutive. And if they're consecutive, that means that they are also supplementary. So that means that PQR equals the sum of, or part of the sum of both PQR and QRS. So if QRS is 110 degrees, then that just equals the measure of QRS, or let me rewrite this, that just equals 180 degrees minus the measure of angle QRS. So QRS is 110, 180 minus 110 gives me 70 degrees. So the property that is used is consecutive angles are supplementary. Okay, let's look at the last one that we have here, which is the measure of angle SPQ. So SPQ is this angle right here. So we just said that PQR was 70 degrees. And I noticed that PQR is across from angle oh, sorry, I got the wrong angle. SPQ is this angle right here. So let's backtrack. SPQ, I notice, is across from the angle that was given, which was QRS. So if it's across from angle QRS, that means it's opposite to it. So if they're opposite angles, that means that the measure of angle SPQ is equal to the measure of angle QRS. And if QRS is 110 degrees, that means that this angle is also 110 degrees. So the property that we're using is opposite angles are congruent. All right, so let's look at example number 2. Example number 2 says that we have PQRS as a parallelogram and we need to find each measure. So the first one that we're trying to find is QR. So QR is located here. And I see that QR is a side. And I also see that QR is 3z minus 4. So if I'm trying to find QR and it's a side, I'm going to look for another side here that has the same variable, which is PS, which is 2z plus 4. Now I notice that these two sides are opposites of each other, so that means that these two sides are in fact congruent. So that means QR is actually equal to PS. So that means the property that we're using is opposite sides are congruent. So now we're just going to go ahead and set up an equation using the setup that we already have here. That's by plugging in. So 3z minus 4 equals 2z plus 4. Now we just solve for z, so subtract my 2z from both sides. So I am left with z minus 4 equals 4. Add 4. So I got z equals 8. But the problem didn't ask me to find z, it asked me to find QR. So QR I see is 3z minus 4, so I'm going to substitute my z for 8. So 3 times 8 gives me 24. And 24 minus 4 gives me 20. So that means QR is 20. But how can we know for sure? Well, we can just plug in 8 here for PS and see if we come out with 20 as well. So 2 times 8, I know that's 16. 16 plus 4, well, guess what? That gives me 20, so I know that my answer is correct. All right, so let's look at PR. So we're trying to find PR, and PR is located here as a diagonal. So once again, remember in parallelograms, we know that diagonals bisect each other. So that means that PT is going to be congruent to RT, and we know that QT is going to be congruent to ST. So if I'm trying to find the length of PR, I know that the parts that have been given to me, which are PT, if I take PT, oops, let me make that as an arrow, I know PT is going to be equal to RT, okay, because these two segments are congruent to each other. So that means the property that we're using is diagonals bisect each other. That's the property that we're using. So now that I have a setup for my equation, I can just now plug in the values. So PT is x plus 9, RT is 4x minus 6, and now we are just doing some simple algebra to solve for x. So I'm going to add my 6 over here. I get 15 equals 3x. Divide my 3, and I get x is equal to 5. But remember, we're not trying to find x, we are trying to find all of PR. So I'm going to take my x and plug it into PT. So PT is going to give me 5 plus 9, which gives me 14. RT is going to give me 4 times 5, which is 20 minus 6, gives me 14. So I know for sure already I'm correct because these two parts are supposed to be the same. So that means that PR is going to equal, oops, I didn't mean to write that. PR is going to equal 2 times 14. So 2 times 14 gives me 28. And the reason why we're multiplying this by 2 is because we have 2 segments, and those 2 segments make up PR. All right, so let's look at example number 3. Example 3 says ABCD is a parallelogram, and we're going to find each measure. So we're going to first start out with angle B, and angle B is located here as 9x minus 5. So I'm going to look for another angle that has been given, and that is angle D, which is 10x minus 19. I see that these two angles are opposite of each other, and we know that opposite angles in a parallelogram are congruent. So that means angle B is equal, or we should say the measure of angle B is equal to the measure of angle D. So remember, the property we're using is opposite angles are congruent. So now that we have our setup, we're just going to go ahead and substitute in the values. So angle D is 10x minus 19, and then we're just doing some simple algebra to solve for x. So we're going to add 19 to both sides. So we end up with x is equal to 14. But remember, we're not looking for x, we are looking for the measure of angle B. So remember, the measure of angle B is equal to 9 times 14 minus 5. So 9 times 14, so 9 times 10 is 90. 9 times 4 is 36, so 36 plus 90 gives me 126. 126 minus 5 gives me 121 degrees. Now, how can I be sure that this measure of angle B is correct? Well, I can just take the same x that I have here and plug it in. So 110 plus 14, sorry, 10 plus 14, that gives me 140 minus 19, that also gives me 121. So that's how I know for sure that my answer is correct. All right, so let's look at AD. So AD is located here as a side, so we're going to highlight that in green. And then I'm also given another side with the same variable, which is BC, side BC. And I notice that AD is opposite of side BC. So what do we know about opposite sides of a parallelogram? Well, they are congruent. So that tells me that AD is equal to BC. And we used opposite sides are congruent. So now that I have my setup, now I can just substitute in the values. 3y minus 1 equals y plus 15. We do some algebra. I get 2y minus 1 equals 15. Add the 1, 2y equals 16. Divide the 2, so y equals 8. But remember, we're not solving for the variable, we're trying to find out the value of the side. So we have AD is equal to 3 times 8, which is 24, minus 1, which is 23. And once again, we want to make sure that we're correct, so we can just take that 8 here, plug it in to the y for BC, and add that to the 15, and we get 23, so that's how we know our answer is correct. All right, so we're going to go ahead and try out a proof. And it says here, for example 4, that we have, we're going to prove that the opposite sides of this parallelogram are congruent. So they give us the parallelogram ABCD, and they want us to prove that segment AB is congruent to segment CD, and segment AD is congruent to segment BC. So let's start out with statement number 1. It says ABCD is a parallelogram. Well, the reason obviously is given. That is the first thing that is stated in the proof. And then statement number 2 says that they're going to draw the segment BD. And that's just simply saying, that we can create a line with exactly 2 points. There's exactly one line given 2 points. Okay, so now statement number 3 is saying that we have segment AB is parallel to segment DC, and it's also stating that segment AD is parallel to segment BC. Well, what's the reason? Well, the reason goes back to statement number 1. Statement number 1 said that it's a parallelogram. So because we know that this figure is already a parallelogram, we already know that the opposite sides are parallel. So that is the definition of a parallelogram. All right, so let's look at number 4. Number 4 states that we have angle ADB, so angle ADB here, is congruent to angle CBD, which is this angle right here. And then we also have angle ABD, which is this angle right here, is congruent to angle CDB, which is this angle right here. And they want to know, why are these 2 pairs of angles congruent? Well, let's think about this. Let's go back to statement number 3. Statement number 3 said that we had 2 pairs of parallel lines, right? But let's focus on lines or sides. But let's focus on sides AB and DC. If I extend the sides out, I'm actually creating 2 parallel lines. And then if I extend BD out, I'm actually creating a transversal. So let's think back to, what was that, topic 2, where we talked about parallel lines and transversals. There are angle relationships that are created when we have parallel lines that are cut by a transversal. So now let's focus on the first pair of angles. So I'm going to call these the blue angles. If I look at the blue angles, I notice that the blue angles are in between the 2 parallel lines. And I see that the blue angles are on opposite sides of the transversal, which is BD, the yellow line. And then if I have the other pair of angles, I'm calling these the purple angles. These purple angles are also in between the 2 parallel lines, and they are on opposite sides of the transversal. So when we have 2 angles that are in between the 2 parallel lines and on opposite sides of the transversal, we say that these angles are alternate interior angles. And that is the alternate interior angles theorem. Let's make that a little bit more visible. Theorem. Okay, so that is the reason why we can say that these 2 angles, these 2 pairs of angles are in fact congruent. And remember, alternate interior angles are in fact equal or congruent. All right, so statement number 5. Statement number 5 says that we have side DB is congruent to itself. So if I look at DB only, so let's erase all of this so we can get a better look. So if I have DB congruent to itself, that means it's a part of some type of figure. Remember, if I have a part congruent to itself. That means it's a part of a figure. And if I notice, DB cuts parallelogram ABCD into two figures. A figure here and a figure here. I see two triangles. So if I were to separate these two triangles, they would have DB in common. So if I have two figures that has a part in common, then that means the reason why these two, this segment DB is congruent to itself is by the reflexive property of congruency. Okay, both triangle 1 and 2 share DB. So now that we've established that there are two triangles here, we can look at the parts that these two triangles have in common. I see that both triangles have a corresponding blue angle, and both triangles have a corresponding purple angle. So that came back from statement 4 and reason 4 with the alternate interior angle. So angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CDB. So we see two corresponding congruent angles, and we also see two corresponding congruent sides, which gives us the reason of angle side angle, where the side is included in between the two given angles. So we have to identify what are the two triangles names that are congruent. Well, the first triangle name that we can start with is triangle ABD. ABD, that's triangle number 1. And then remember they're corresponding, so that means that the sides and angles have to match up with the name. So the second triangle would be named CDB. So triangle ABD is congruent to triangle CDB because of the ASA triangle congruency theorem. We have two corresponding angles with an included side that's also congruent to show that these two triangles are congruent. So we're now at the last statement. The last statement, remember, we are trying to prove that the opposite sides of this parallelogram are congruent. Well, I've already showed that the two triangles that have been created in this parallelogram are congruent based on ASA. Now, if I know that the two triangles are in fact congruent, then I know that the other parts of the triangle are also congruent. So that means side AB is going to be corresponding and congruent to side CD. Side AD is going to be corresponding and congruent to side BC. So because they're corresponding and congruent in both of the triangles, I can say the reason for the opposite sides of this parallelogram is congruent based on C, P, C, T, C. And that concludes our proof. All right, so you're going to take the time now to try the next two problems on your own in your notebook. So go ahead and pause the video. All right, welcome back. So we're going to go ahead and work out these two problems in your lesson examples. So the first one says, find the measurement indicated in each parallelogram. So we're trying to find this little angle right here. Well, first we have to identify what's been given to us. So I see that angle T in the parallelogram has been given to us, and I see that there is a whole measure of angle S that has been split, but it has been given both of the expressions to represent both of the angles. I already know as a setup that the measure of angle T and the measure of angle S are consecutive. They're right after each other, one after another. So because they're consecutive angles, I know that the sum of those angles have to be 180 degrees. Well, why? Well, we know that consecutive angles are supplementary. So that is the property that we are using. So now that I have a setup for the two angles, I can now just go ahead and substitute the values into those angles to try to find the measure of that little teeny angle right there of 7x plus 9. So T I already know is 95. And then S is split up into two angles, so that is 7x plus 9. And then we're going to add that to 4x plus 10. And we know that all equals 180. So now I can go ahead and solve by first combining like terms. So I have an 11x, and then I have a 95, a 9, and a 10. So that gives me 114, which equals 180. Now we're just going to go ahead and subtract. So I'm left with 11x equals 66. Divide everything by 11, and I have x is equal to 6. And remember, we're trying to find that little bitty angle right there. So we're going to take our x equals 6, and we're going to plug that in. So when we plug that in, we have 7 times 6. 7 times 6 is 42, plus 9, which gives me a 51. So I know that's 51 degrees. But how do I know for sure that's my answer? Well, I can plug in my x here, where it has the 4x plus 10. So 4 times 6, which we know is 24, plus 10. So we have 24 plus 10. That gives me a 34 degrees. And if I add 34 plus 51, that gives me 85 degrees. So I know angle S, this is the measure of angle S, right? That's 85 degrees. Now, remember, we said the measure of angle S and the measure of angle T are supplementary. And supplementary means that the sum of the two angles equal 180. So if I take a 95 plus 85, guess what that gives me? 180 degrees. So I know that my answer is correct. All right, let's look at the next one. It says here, we are trying to find FW. FW is located here along diagonal FH. And remember, diagonals of a parallelogram bisect each other. So that means that we have HW congruent to FW, and we have GW congruent to EW. So we are using diagonals bisect each other. That is the property that we're using. So they give us that FW is 5x, and they give us that WH is 6x minus 3. So because these two segments are equal to each other, I am easily able to set up an equation. So that is 5x equals 6x minus 3, and I can simply solve by doing some algebra. Oh, well, let's not go that way, because then I'm not going to have anything on the other side. So we're going to subtract the 6x. I'm so used to subtracting the smaller number from the bigger number. So I have negative x equals negative 3. To get rid of that negative, we're going to divide by negative 1. So I have x equals 3. But remember, we're trying to find FW. So FW, remember, was 5x. We just plug in that 3 and we get 15. But to be sure that we are correct, we can just simply plug in that x that we got into WH. So we get 6 times 3, which is 18, minus 3, which we know is 15 also. So that's how we know for sure that our answer is correct. All right, ladies and gentlemen, just to recap, so we are able now to answer our essential question. What do we know about the sides and angles of a parallelogram? Well, we know that the opposite sides are congruent. We know that opposite angles are congruent. We know that the consecutive angles are supplementary. And one last one, we know that the diagonals bisect each other. All right, so that means that we can conclude by you going to your parallelogram family page, and we can mark off now all of the things that we've learned about parallelograms. So opposite sides parallel, opposite sides congruent, opposite angles congruent, and diagonals bisect each other. So as we go to our rectangle, rhombus, and square, we'll be marking off in our chart which ones are properties of the specific figures. All right, ladies and gentlemen, that is all for me. Your responsibility is to go to the student portal and complete your homework in the HMH online textbook. That will be due January 10th at 11:45 p.m. Have a wonderful day, ladies and gentlemen, and I will see you next class.